Welcome back, guys. Today we're going to learn about how to calculate density. You'll recall last week we learned how to calculate pressure. And about a week and a half ago, or 2 weeks ago almost, we learned what density was. And we learned the definition of density, and basically density is the measure of the amount of stuff in an object, like the measure of the compactness of an object. The more density, the more amount of stuff in the object. We also learned that liquids, like solids, have densities. And we learned that if an object has a greater density than the liquid's density, then that object is going to sink. Whereas if that object has a smaller density than that liquid's density, the object's going to float. Now we're going to learn, how do we get that density? What calculation is involved to find density? Now, if you look up at the top right here, you see three equations. This is like what we've been doing. You're given an equation and you're asked to solve. You did this last week with pressure. We've done it all year with speed, velocity, etc. So, you'll notice the first equation is when you're trying to find density. So this is when you're being asked, what is density? Or what is the object's density? You're going to pick this equation, which is D equals m over v. Density equals mass over volume. And recall, this line here means division. So I'm taking my mass and I'm dividing it by the volume, and that gives me my density. Now, you can also take the density and the volume of an object to find its mass. So you're going to use the second equation, this one right here, if you're being asked to find mass. So the question might be, what is the mass of the object? What is the unknown mass of an object, etc. And with this equation, you're simply going to take your density and your volume and you're going to multiply them. That will give you your mass. The last equation we have is for volume. This is going to be used when you're trying to find volume. So again, the question would ask, what is volume? What is the volume of that substance? And you should have been given mass and density. You'll use your mass and density to find your volume. Now again, look, for volume, you're going to take your mass and you're going to divide it by your density, and that will give you your volume. So, the unit when asked to find density is either going to be grams per milliliter or grams per centimeter cubed. It depends on what unit your volume is. So recall when we were learning speed and velocity, our unit for the most part was meters per second. M per S. That was because speed was your distance over your time. So we took the unit for distance and divided it by your unit for time. Meters over seconds. Meters per second. Distance, meters, time, second. For speed, this was our unit. Density works the same way. You're going to take your mass unit, which is almost always going to be grams, and put it over your volume unit. Your volume unit is either going to be milliliters or centimeters cubed for this class. So you're just going to go, oh, in this problem, my volume is centimeters cubed. So that means your unit for density is going to be grams per centimeters cubed. If you have milliliters for volume, your densities units are going to be grams per milliliter. It just depends on the word problem. We're going to see that when we do the practice problems down below. I also just want to point out, these are the units for density. So this and this are for density. Mass, your unit is always going to be grams. Your volume is either going to be milliliters or centimeters cubed. So these are only for density. Make sure you're filling the notes out while we're doing this. Okay, now we're going to look at the two problems below. These are also on your notes that were posted onto Google Classroom. So if you notice, this equation, this setup, what we're going to be doing is almost identical to last week's pressure calculations. But now we have different variables. So you'll notice in the first problem, it's asking us to find our density. So we're going to pick equation 1, which is this guy. Density equals mass over volume. And we're going to realize in the problem, it says you have a mass of 20 grams. The grams gives it away and tells us its mass. The word problem gives it away and tells us its mass. So because 20 grams is mass, it's going to go where m is in the equation, which is on top. And because we know our volume is 10, we're going to put that where v would go, which is on the bottom. Again, the units give it away. You know 10 centimeters cubed, this is going to be volume because it's centimeters cubed. Because this is grams, you know that this is mass. You don't have density, so you're obviously going to have to find density. It also says that in the problem, but I'm giving you like clues to help you figure these out more easier. So once you plug in your numbers, 20 for mass, 10 for volume, you're going to divide my numerator by my denominator. 20 divided by 10 gives me 2. And you'll notice in this problem, my units are grams per centimeter cubed. Why is it centimeters cubed? Because my volume was centimeters cubed in this example. Okay. Now let's look at number 2. Again, in number 2, it's asking us what is density. It gives us mass, it gives us volume, but it does not give us density. So again, we're going to pick equation 1, d equals m over v. Now, we look at the word problem. It tells us we have a mass of 40 grams. 40 grams mass. 40 grams is going to go where m is, 40 on top. It then tells us we have a volume of 25 milliliters. That's our volume. Again, milliliters gives it away, its volume. So our 25 milliliters is going to go on the bottom where the V is. Then we're going to do the same thing we did before. 40 divided by 25, which gives us 1.6. And our units for this problem is grams per milliliter. It's milliliter because we used milliliters in this example. So these problems are exactly like the problems we've done before. We just have a different variable. We're trying to find a different thing. Now, the last thing I want to talk about before I let you go is I want to connect this concept to what we learned about a week and a half ago. Let's look at number 2. In number 2, our object has a density of 1.6 grams per milliliter. If I had water, which universally has a density of 1 gram per milliliter, I would want to know, can my object float or sink in water? So again, my water has a density of 1 gram per milliliter. My object number 2 has a density of 1.6 grams per milliliter. I'm going to ask you at home, will my cube sink or float? Why? I'll give you 10 seconds. Exactly. Our cube is going to sink. Why? Because this density is greater than my density for water. And like we learned about, because my object's density is greater than the liquid's density, that object is going to sink. So there you have it. We now know how to calculate density, and we know how to connect it to putting them in liquids and determining whether they sink or float. This will come in handy when we do our lab on Wednesday. Okay, that's going to wrap us up for today. What I need you guys to do is now go to the practice problems and submit them. Complete them and submit it to Google Classroom. There will be an answer key posted on Tuesday. Have a wonderful day, guys.